Okay, this is a video to help you on 6.1 and 6.2 homework. This is 6.1 number 14, which I think is kind of interesting, so I'm going to walk you through it. It says, so here you have this probability distribution, okay, where if you win a grand prize in a lottery, the probability of it happening is this, or if you win 200K, it's something, etc. Okay, and it wants you to complete parts A through C. So it says if the grand prize is 14 million, find and interpret the expected cash prize. Okay, so this right here is a distribution for the cash prize. So you'd put 14 million in, and expected value is just the sum of every value times the chance of it happening. So you would do this times this plus this times this, etc. Or if you're smart, you would put this in list 1 and this in list 2 and do 1 var stats L1 comma L2. All right, so that'll get you A. Then it says the expected profit. Well, you could do that in two ways, because the first one was the expected win or the expected prize. Profit, it's saying, look, if you cost you $1 for your ticket, then the profit would be whatever you win minus $1. So you could redo what you just did and change all of these X values to the same amount but minus $1. So this one would become, you'd lose $1, you'd get $2, you'd get $3. Or another way to do that would just to take and you would then do one variable stats, etc. Or a shortcut for that would be to just take this average, the average that you got, the expected value from the previous one, and just minus $1 at the end. So in this case, our expected winnings was 0.31, but minus the $1 that you paid, and so then your expected profit would be negative 0.69. So again, you could just minus 1 at the end, or you could redo the whole chart and do list 1 comma list 2. On that note, okay, it says, to the nearest million, how much should the grand prize be so you can expect a profit? Well, a profit means that this value right here is over 0, or at least 0, okay? So you could work with a new chart, but assuming we don't want to make a new chart, we know that the average from the current chart minus 1 has to be 0, okay? So at least you didn't lose anything. So now the question is, what does the grand prize have to be? So we could say that we want to set up an equation. So the idea again is that we want the expected value or average from this chart minus 1 to be greater than or equal to 0, okay? And so we want to find when it's 0. We want to find when a profit would start. So to find the average again, it's every value, so the ground prize times the probability of it happening, so it would be this 0.000 whatever, right? And so you are going to have to write all of this out, plus okay, so basically here's the formula, but shorthanded. It's the sum of every value times the probability of it happening, so that's the expected value, minus 1, here's our minus 1, and that needs to be greater than or equal to 0, because that would give us when our profit is above 0. Now this is a lot to add up, but if you're smart, okay, we're trying to find for what the grand prize would have to be to make that work. You could get this value right here out of your table. So if you looked at it, here's your table. Okay, we're solving for this value right here. Here's your G. Okay, so this part we have to keep in our formula right here. But from here to here, that is all of this stuff, right? So you could put that in your calculator and just take off the top, don't include this, do list 1 and list 2, 1 var stats again, L1 comma L2, and get the mean of these, because that's what we want. every value times the chance of it happening. So then you would have the grand prize times the probability of it happening plus that value that you just got out of your calculator, which is the mean excluding the ground prize, minus 1 is greater than or equal to 0. Okay, you could combine this into some number, dot, 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 solve for G. And that's what the ground prize would need to be. And that is how you'll do this one. They actually walk you through this fairly decently in the example. I had a couple people ask me for this one, and I thought we would need to do a larger calculator cheat. So I said I would put it on the internet today, which I'm doing, but actually the example walks you through nicely. Now let's look at 6.2. All right, 6.2, number 12, okay? First off, I'm gonna read it to you, and I don't like the way they asked question A, which is why I'm gonna show you. And then B is tricky, so I'm gonna show you a trick. Okay, according to a survey, 28% of residents of a country is 25 years or older. Excuse me, let me try that again. According to a survey, 28% of residents of a country 25 years or older had earned a bachelor's degree. So the probability of being in that age range and earning a bachelor's degree is 0.28. That's our chance of success. You are performing a study and would like at least 10 people in the study to have earned a bachelor's degree, okay? So it says, how many residents of the country, 25 years or older, do you expect? Expect is the average. So you're going to be using that formula, the sum of every value. Oh, I lied. This is binomial. And the average for a binomial is the number of people you survey times the probability of success. So that's what I have here. Here's the thing, we don't know what the average is going to be, and they're expecting you, based off of this wording of you'd like at least 10 people in the study to have earned a degree, they really should have said, we'd like our average to be 10. So we have to let the average be 10. I don't like their wording, I don't think it's very clear. But if you assume that, you now have enough to solve it, because what they're saying is, how many people do you need if the average is 10 and the chance of success is 28? And then you could just solve for n. So in this case, divide both sides by 0.28, and you would need at least 28 people. So that's how you do A. B is a little more confusing. It says the number of randomly selected residents with a probability of 0.991 containing at least 10 who have earned a bachelor's degree is however many. What they're saying is, right, we don't know how many people they've surveyed. Maybe they're going to survey 28, but we don't know. But this is how it's going to look. All right, and these are all the things that could happen. You survey 2 people, okay, and 0 of them have a degree, 1 of them has a degree, or 2 of them has a degree. Maybe you surveyed 12 people and 0 have a degree, 1, 2, 3. These are all the outcomes up to however many people you survey. So 0 could have a degree, 1 could have a degree, 2 could have a degree. And what we want is the probability that at least 10 have a degree of however many we survey. So we want this. This is the probability of x being greater than or equal to 10. And you'd have to add up all of these. This one, plus this one, plus this one, which we don't even know how many people we need, because that's what we're trying to figure out, is how many people would we need to survey to have this probability be equal to 0.991. How many people in our group would there need to be to have the chance of 10 or more having a bachelor's degree be 0.991? So here's the deal. The formula to find that is 1, because the whole thing is there's a 100% chance of one of these things happening. So 1 minus 0 up to 9. Because if you subtract the green stuff, then you're left with what we're looking for, which is the combination of all those red probabilities. So 1 minus binom CDF, because it adds up probabilities to the left. Okay. We don't know how many people we're going to survey, but we know the chance of them having a degree is 28%. And we want to subtract 9 people or less. And basically, they want you to just keep plugging in to this equation, plugging in all the different n's you could think of until you got to the lowest one that equaled 0.991. And this is why I wanted to show this to you, because you can kind of cheat on your calculator. You can go to y equals and type in 1 minus binom CDF x, because you want it to plug in for n. There's your chance of success. So in this case, it should be 2, 8, comma 9, and hit enter. And it's going to plug in all of these possible n's that it could think of. And then you'd hit second table. Now, I know that it's going to be a fairly high number. And so you could go to second window or table set and tell it to start maybe at 50 or 20. So you don't have to scroll as much, but it doesn't matter. Now, if you go to second table, hello, okay, which you can see, and it's hard to see here, but when there's 50 people in your survey, that probability would be 0.92. And you just keep scrolling down. My air serve went off, but we're okay, we're almost done. You just keep scrolling down until you get one that matches that probability. And we're looking for, in my problem, 0.991. So 92 would be, or 62 would be 0.990. So I'm thinking their answer would be 63 is what they're looking for there. Okay, so that's your shortcut for that one. Let me know if you have any questions. Thank you.